Galileo, the European satellite navigation system, named after Galileo Galilei, is back on course after decisions of the European Union on how to finance it. ESA, in partnership with the European Commission, will launch the second Galileo satellite, Giove B, later this year. The Giove satellites were designed to test the technology which will finally be used aboard the entire Galileo constellation. This is Giove B at ESTEC, the ESA facility in Holland, where it was prepared for its launch with, for example, testing of the solar arrays designed to power the satellite in space. Giove B, the second Galileo satellite, will take advantage of the knowledge gathered from the 2 years that Giove A has spent in orbit. During this time, ESA has been able to study how the state-of-the-art technology aboard Giove A has performed.
We have proceeded by steps. Giove A first, Giove B providing added technological features in space. And we are now building the first 4 satellites of the final constellation, the so-called IOV satellites. Those satellites are being built. They will be assembled as of next year. And the launch is planned by the end 2009, early 2010. And this will provide the first operational satellites for the deployment of the overall Galileo constellation.
One of the key elements for success of the Galileo system is the atomic clocks the satellite will carry. One of Giove B's most important roles is to test the accuracy of these clocks, as time is at the heart of any positioning system. Giove B will carry the most stable clock ever flown in space. This high-precision passive hydrogen maser clock will have an accuracy of 1 nanosecond per day, meaning it will only lose 1 second in 3 million years. Another of Giove B's roles will be to test a new signal type recently agreed on between Europe and the United States. This signal is very important for interoperability between existing navigation systems, making Galileo compatible with the 2 other current positioning systems, America's GPS and Russia's GLONASS. In future, anyone using Galileo will be able to employ the same receiver to calculate his position from signals sent out by a combination of these navigation systems. When complete, Galileo will be a constellation of 30 satellites supported by a network of ground stations, creating a veritable global network for Europe. This combined network will be able to provide a multitude of services that will affect every level of people's lives. This will range from the minor, like avoiding traffic jams or managing one's banking, to uses such as international search and rescue operations and air navigation services. Galileo will not only afford Europe independence from other systems, but also mean that Europe can be more competitive in a rapidly growing global market where new technologies using navigation systems are at the forefront.
We are absolutely confident. We have tested ourselves and our technology over the years. We have developed the know-how in industry. Industry in Europe is very well prepared to be at the forefront of technology and satellite navigation services in the future.
So when it's launched by Soyuz from the Baikonur Cosmodrome this spring, Giove B will, technologically speaking, be the forerunner to the spacecraft that will make up the overall Galileo constellation. The Giove satellites are the way for ESA to test and refine the systems on which the Galileo satellites will depend. By going through these absolutely thorough testing stages, Galileo will be able to provide state-of-the-art services with outstanding accuracy, availability and integrity, offering a guarantee that isn't provided by any other system today.